All right, good people. Let's make this thing happen. Y'all know the vibes. We are another day, another opportunity to tap into this full stack bag. And what better way to do that than by building out some full stack applications? So last time we connected, we were starting to work on this really dope PERN stack app that is a combination. Basically, when I say PERN stack, I basically mean a stack that is utilizing Postgres, Express, React, and Node. And so, like I mentioned last session, different stack components will create different types of frameworks that you use in your full stack experience. And as a shorthand for some of the more common kind of configurations that you'll see in production, we kind of have some acronym based signifiers for some of these different stacks that are pretty common. So one that's really common is the MERN stack, which you hear a lot about: Mongo, Express, React, and Node. Another one is Postgres, Express, React, and Node. So if you hear MERN stack, PERN stack, sometimes you'll hear the LAMP stack that is not related to JavaScript, but Linux, Apache. Sometimes you hear people say PHP or switch it with Python. So all these different types of stacks are utilized to create, full stack experiences. And so right now we're working on the PERN stack and creating an opportunity for ourselves to get familiar with a stack, a singular stack. And from there, hopefully you can understand when you start looking into some of these other frameworks, how they would replace aspects of the things that we've built here. So just give me a show of thumbs that you're here rocking with me, ready to go, ready to tap in, dive into some more code. You know the vibes. That's what we do here. That's all we're here. That's all we're about, is getting into this code. All right, cool. Thank y'all. I appreciate that. It looks like my class is awake today. I love it. Great. All right, boom, shakalaka. Let's make it happen. So here's our current status of our application, right? At the end of our last bit of hacking, we coded together our front end and our back end and basically got them running on the same server, hosted at localhost 8000. We also were able to leverage some API calls to do things like make sure that we can get back all of our links from our Postgres table, and all those pieces are being connected through our Express server that we created. So just take a look back at the code and just make sure that we're all on the same page here. I think it might be helpful to just start. Let me just close all these files so that we don't get too lost at once. But we're going to just start with a kind of brief code review of what we got here. So right now we have a big project. Our main project is called FaveLinks API Postgres. And this is our big folder containing both our client side code as well as our server side code, right? On the server side, to start there, we have two very important files: the index.js, which is where we defined out our Express server, and the queries.js, which is where we started creating our connection to the Postgres API, to the Postgres database server, and starting to create some queries to the Postgres database server that allow us to interact with the data in a more compelling way, right? So to break that down, right, we started by creating our server-side application first. And the server-side application, really, all it really needs, especially when you're working with Node and Express, is very simple. To create a server-side application in Node, you just have to initialize an npm project in a empty folder. So because our main folder was an empty folder at first, we started a new npm project inside of there, and that got us our node modules directory. It also got us our package.json, and the package-lock.json also comes, basically gets created whenever we start to install packages from npm. The two packages we needed to install in order to get our project up and running was the Express package, in order to allow for us to create our Express server. But then we also use another package called PG, which created the Node Postgres connection that allows for us to use Node and connect to a running Postgres server. using what we call a pool, which is essentially an object that creates an established connection between your server and the Postgres server. So Postgres and most databases run on their own server. So it's typical that on a machine, you'll have a specific port responsible for hosting your database server. And that server will be where if you want to create specific actions in relationship to your database, that's where you would have to direct all of those requests is to that particular server on your machine that's responsible for your database. And for us, it's no different, right? We launched a new Postgres server that's running on the default port of 5432. The way we did that was by installing Postgres on our machine. And whether you're on Windows or Mac, you can install Postgres, or Linux, you can install Postgres and create a running Postgres. Running the Postgres service on your local machine essentially runs the Postgres database on a particular port of your local machine. Typically in production, you might create a server responsible only for your database and have that server running and have a separate server running for different aspects of your code's architecture. But for us, we're in development phase. We're just building out some stuff to test it, get some familiarity with these different frameworks and make sure that we are on the right track in our full stack journey. And so we have all of these servers currently running on our local machine, but they're running on different ports. And so the Postgres server running on port 5432, we were able to interact with through the terminal and the command line. And we're able to, essentially run queries and all types of stuff by utilizing the Postgres interactive terminal. If you see here, down here, we were able to do a number of different things. So like, for instance, these little queries that we had defined for ourselves. So let's just go ahead and just select all from links and then drop that in the interactive terminal just so, whoops. Well, let me not waste time right there real quick. Anyway, y'all remember we were utilizing the Postgres interactive terminal to make these requests to our particular instance and to get the insight we needed on how we were working with the data inside of our table. So where we left off last was we have an established connection to Postgres, and we also have the ability to start getting back that data, right? And so we saw that through our ability to create our first route, which was the /links route that was tied to our connection to get the links back from Postgres. So this command, select all from links, was done in order to get back this data. And once we get it back, we send back a response with the JSON with all of the particular rows in our table. This get links method that essentially calls our pools query method is our first query route that we created in order to interact with the Postgres database. And we essentially created this method, get links, so that we could export it from this particular file. And then back in our Express application, we're able to create a new route that is responsible for calling that particular method whenever the user goes to /links. So whenever a user performs a GET request to /links, it actually calls this GET links method that we created in the queries file, but we were able to import all the methods that we will add into our queries file using the import and export syntax in Express that allows for, or syntax in JavaScript that allows for a node basically to allow for us to export a number of different methods and then import them in an object that then we can use to refer to all of those particular functions that we exported. So today what we're going to do is we're going to add to all of these different files, right? We're going to add a new route to our queries file here. And we're also going to add a new route we're going to add a new handler to our queries file. We're going to add a new route to our Express server file, this index.js. And we're going to mess around with the client side just a little bit to make sure that we are able to make sure that that new call is happening. So to pivot attention a little bit to the client side, because we just kind of talked through what's going on the server side. On the client side of this application, we essentially created a separate folder or directory for our client application that's called client here. But this application is essentially its own React project, right? So there's a number of ways that we could have added this folder for our client side code in here. One way would have been to just use the create React app tool chain and launched a new React project inside of this folder called client. Another way would have been, if this wasn't a React project, we just create a folder and add the necessary files for the client side inside of there. But all together, right, the idea is inside of this folder called client, I have everything that I want the user's front-end experience to consist of. Because this was a React project, the client folder actually contains a number of subfolders inside of it that are responsible for our React experience, right? So the source folder is where all of our components live. The app.js is where we first render onto the screen, and that is bringing back this link container. That link container is one of the components, and that's where essentially we are rendering this kind of div with this my favorite link, add a new URL, etc., which is what we see currently on the front end, right? The reason we can see this on the front end at localhost 8000 is because after we finished creating our front end experiences and we had a solid first version of our client side application, we were able to build this project, this client side application, so that it could be ready for production and ready to be on a server in production, essentially. So to do that, we made use of the React scripts build functionality, which allow for us to take a create React app project and build it and create basically a folder that has all of those same files that we were just talking about in the source folder, but all of them bundled together in a way that is able to be a little bit less large, in the sense of it's not so many different files, not all the node modules, etc. All of those things are kind of minified down, shrunk down into a series of files that we can host statically on a server. And so the build stage of working within the React landscape is important to note, because it is an important process. This is an important part of the process when it comes to getting your files ready to host in production. Because you want to host static files in production that are able to be just held on the server and referenced by the server. And by nature of how a lot of these development libraries work, those files aren't by start static. They're using a lot of dynamic processes in JavaScript to render things, but eventually we want to turn it back into its basic JavaScript, HTML, and CSS. And that's what the build stage does in the process of getting our code ready for production. To do this build stage, all we had to do was go into the client directory, and then we ran npm run build, which is a script. Whoops, I'm in the wrong one. Where's this? Which is a script that comes built in with the create React app toolchain, right? So we did npm run build, which ran this command React scripts build, which turned our project into, which created this build directory for us that we can reference when we're ready to deploy and ready to host files on a server. And so whenever we're working with a client-side application and we want to make changes or we want to essentially have a new version of the client side pushed into production, we need to rebuild that application and make it so that we can host the new files on our server. And whether it's React, Create React App, or any other library, there's a process that that you use to do this building of your production ready assets. And then you're responsible for creating some type of way to update those files over time. And there's a number of different ways and strategies that dev teams nowadays want to automate that process of, building the latest version of the code and deploying it to a server, testing it in between to make sure there's no bugs being pushed into production. And those are all things that we can continue to talk about once we get a better grasp of just this first part of building the process of having both a client side and server side experience. So a lot of stuff going on in this particular file right here. We clearly have a lot going on with relationship to the the main project. We have our client side stuff going on. We got our server side stuff going on. But hopefully you can see that what's connecting these things. Oh, we didn't really get to that part, but what's connecting these things right now is we made a server call in our client, in one of our client files right here in the link container. We made one API call to get back the links, right? And getting back the links, basically, we're setting ourselves up for the process of not only hosting our client-side application on localhost 8000, but also making it so that our client-side application can make a request to our server, get back some information, and we can use that information inside of our client application, which is where we're hoping to get to. And hopefully by Wednesday's next session, we'll be able to walk through this entire app and make the actual calls that we need in order to wire up our client-side application to the server and to everything going on there as well. So like I said, we definitely got a lot going on, and it is not not an easy amount of stuff to grasp, but it is, like I said, a good example of us working within a full stack experience and making the process a little bit easier for ourselves in order to host our code as well as to make these server calls. And so if you're relatively understand what's going on, just give me a thumbs up just for my own metrics of where people are at. But we're going to go through a lot of this today and kind of redo some of what we did last time so that we get another example to look at what we got going on here. But yeah, just if, somewhat making sense to you, it's good to know. And, you're on the right track. Just bear with the process. All right. Okay, cool. Yeah, I figured out what was going on. I didn't connect to our table when I was trying to make that Postgres call earlier. So that's why the interactive terminal didn't respond with anything there. Okay, all right, let's do it. So today, essentially what I wanted to do is kind of just add on to the code that we kind of got going on in here and really kind of walk back through the processes so that we can essentially see how we might extend this application both on the client side as well as on the server side. So to do that, to start off, I want to just go back to the index.js and just kind of recap what's going on in here right now, right? So we have our Express app getting started, right? The Express app is getting, we're importing Express from our node modules. We're also importing the path module, which comes built in order to do some of the static file hosting. We're importing our queries.js file that we created just so we can make a reference to all of those different functions that we're going to end up writing that are pooled to the Postgres server. But, after that, a lot of this stuff is kind of common Express application logic going on. So the first thing we're doing is creating a new application in Express. The second thing we're doing is we're telling that Express instance that we're going to be parsing some JSON. And in order to parse this JSON, applications that are sending us JSON need to make a request where the content type header shows that it's sending us some JSON. And so we're going to see why that's important in a little bit. But basically, these next couple of lines, these lines 10 and line 12, are allowing for us to create what's called middleware in our Express server. So middleware you can think of as code that runs in between our requests that allow for us to pass some logical expressions in so that we can ensure that all of our requests are being handled in a specific way. Some middleware is pre-built into Express, but some middleware you might create. And maybe you want to make sure that before you send any data back to a route, or even if you want to make sure a user can't get to a particular route without being authenticated, for instance, you might create some middleware that verifies that the user is authenticated prior to allowing them to get to that route, right? So middleware can be a very important aspect to your server-side experience by essentially adding some layers on top of how your requests and responses will be handled. The URL encoded middleware here is making it so that we can parse data types where if the data type is showing that the URL is being encoded, which we'll see a little bit more about what these content type things mean in a bit. It will process and look at those requests as well. So these are just us adding a couple bits of middleware that will help us working with some of the requests that we're going to make. But after that, we're doing some logic to host our React application as a static file. And the reason we wanted to do this was so that we can later send a file within that folder of static assets to our users at the root route. And whenever a user goes to our home route, our root route, right, we would send them back the index.html that came in the client build folder. So in that build folder, we talked about that React bundled up for us and everything. There's an index.html file inside of there that when you access that index.html file, it knows how to connect to the JavaScript files that are linked to it and the CSS files that are also linked to it in order to show you that React experience that we created. And so that's how we're able to show the React project at the end to the user, is by sending this index.html file from the client build folder down to the user as a file. And in order to do that, that's why we needed to have this path module installed that allowed for us to create a path directly to that particular file. We can also create paths directly to folders. So on line 14, you see a very similar body of data here as you do. You see a very similar body of data here in the path, right, as you do here in this path, right? The only difference is that this path on line 19 extends all the way to the index.html, whereas the one on line 14 extends just to the folder for the build folder, so that we can host all those files as static files. And here we're very specifically saying, hey, I want to send you a very specific file inside of that folder. That makes sense. Just give me a thumbs up to just understand, just how we're going to host these static files and folders and whatnot, and make sure that we are referencing the right data that we want to reference for that particular part of the client side. Okay, cool. So sending files is one aspect of how we can create our routes, but we also can use our routes to send data, right? And send data back to a client that is requesting some data. So here we're getting some data back from in the format of this HTML file. But we also created another route called get/links that calls this database get links function. And that get links function is defined here in the queries. It's this function right here. And that function, as you can see, is responsible for creating a query to our database that is getting all of the links that we saved on our database and sending back some JSON if there is sending back some JSON with this data when it is successful. And if it's not successful, right, if there's an error in any part of running this query, we just throw an error, which means that if the client is expecting some data, they're going to get back an error and rather than getting back some actual successful result. The throw syntax here is one way for your functions to send back an error if something goes wrong, especially in the asynchronous space of working with code. And so the way that the query works within this pool, right? We established a connection to our Postgres database. And with that connection, we can run queries. And a query is essentially just a string that we would have typed in to interact with the Postgres database. So there are a number of different things that we might do within that space, right? We might go get some information. We might want to write some information. All of these different things allow for us. We might want to update some information, delete some information, right? All of these different things are ways of interacting with the database. And we structure queries to the database to do those various tasks. All right. So what we're looking at here on line 12 is a selection query where we're selecting some data to return back from the table. The value of a query like this is in specifying what type of data do we want to get back from the table, right? And so here we're saying we want to select all, we're using the wildcard symbol here, all the data from our table, which we call links. Then we can add some other parameters to the query, such as like order by, which is a SQL command that allows you to structure the response of that query in an order, right? In a logical order. So we did it ascending by the ID and got back all of those particular links. Once we got this data, so this pool.query is going to return this data in an asynchronous callback call function here that you see here, like we call back another callback function. If there's an error, it's going to give us an error. If there's not an error, it's going to give us some results, right? Or some data back. And if there's an error, that's why we're able to then manipulate that error from this particular function. Otherwise, we're able to just send back our data for our application. All that we did to finish up this particular file was after writing this function, this get links function, we exported it. And we exported it by way of using some of the JavaScript syntax for creating export modules, which are basically objects of code that we want to be able to reference in other files, right? So the get links function is a function that we might want to call somewhere else. So in order to call it from a different file, we need to export it. And so the syntax to export a function or anything out of your code is to use the module exports functionality. And we can create an object like you see here. We can create a new object that has a number of different references inside of it that we can then reference later when we import this particular object into a different file. And so that's what's happening here in the index.js, where we say const db gets require queries. Here, this require queries is basically getting back this object that we were exporting. And by way of getting back that object, clearly inside of this object, there is a get links value. And so that's why we're able to do this database.getLinks to reference this particular function here. So if I wanted to add new routes that were related to the queries, right? I can add new functions in here and export them in a similar way, and then reference them in a similar way here as well. And that is all valuable for creating an easier way for me to separate out the code for my database stuff from the routes that I'm returning in Express, which helps keep the files a lot more readable and just a little bit easier to troubleshoot over time, because they're not all just everything all happening in one place. We know that if something goes wrong in the queries function, right, it's clearly an error here. Whereas if something goes wrong with our route, it's clearly an error somewhere in here. So all of that is very helpful to just keep in mind as we're building these things out. Okay, all right. So that's a little recap of kind of everything going on in the files so far. Like I said, my goal today is to just kind of continue to extend the logic a little bit and make it so that we can just add some more, add some new routes here and get to the point where we can manipulate some of this data in both a passive way, like get it, and then a more active way by posting to our database and to our table. So here's what we're going to do to get there, right? So first things first, right? We talked a little bit last time about a particular paradigm when it comes to building out APIs connected to databases called CRUD. Just show a thumbs. Give me a thumbs up if you remember what CRUD is, or if you remember hearing about it and you're like, oh yeah, CRUD. Yeah, that makes sense. CRUD. All right, I see a couple folks throwing their thumb up. Thanks, that's what's up. Yeah, so CRUD is a paradigm that we utilize within our APIs, and specifically when we're working with data that we're going to be utilizing in when our application is working with data. It's not a paradigm that you see when you're not working with any data, but it's one that you'll see if you're creating an API that's responsible for managing data. Yeah, like the folks in the chat just throughout, right? CRUD stands for create, read, update, and delete. And those are just 4 important actions that a user or a client might want to take with reference to working with a database and the various data within that database, right? So I might, as a client, want to create some data and put it in the database, right? I might want to read all the data that's inside of a database. I might want to update data inside of a database, and might want to delete some data within a database, right? So these 4 actions are very common actions that we take when working with data and working with databases. And because they're very common, they kind of got their own paradigm. And that's why we call it CRUD. Like everything that you hear as an acronym is because it became a paradigm that folks are commonly using in their structure, right? So the CRUD framework is a very common pattern that you'll hear about often. And if you work on back-end systems, it's great to tell folks, hey, yeah, I'm familiar with CRUD and, building out CRUD APIs, those types of things. People will be like, oh yeah, I know what you're talking about. That's what's up, because these are very common paradigms that we use often. So pop little quiz, right? What of these 4 methods is this get links method most referencing? Is it a create method? Is it a read? Is it update? Or is it delete? Get links. Drop it in the chat. What y'all think?
Read.
Yeah, a read, definitely. So yeah, definitely, right? So get links is reading data from our database, right? Is going into our database and saying, hey, let me get back some of the information from inside of here, right? I don't have anything I want to change. I just want to read the data. So if you just can send me the data, perfect, right? So this is a read method. This is exactly an example of a dope read method. So that's great, right? We got one of them done. we already got a nice CRUD method already established. Wonderful, right? So we got a couple other ones that we might want to learn how to create. And the process of creating these methods also correlates to the process of working with our various HTTP methods that we use when we are working with backend systems in general. So if you remember, there's a number of HTTP methods that we can utilize in order to connect with our database, or not database, what am I saying? To connect with our server, right? So a server is listening, HTTP server is listening for these different types of requests that we might want to say, hey, we're doing these things to get some data, right? So the common methods, there's a couple more that you see here because this is the Mozilla Developer Network and they're going to tell you everything. But so you see a lot of different methods here. But the most common ones definitely are the get method, right? Which is the method that just basically tells the server, hey, I just want to get back some of that data that you have, right? It's a retrieval method. So when we talk about reading data, right? Typically, if I'm reading data, I'm going to want to get the data. Right? If all I want to do is retrieve and read, then I might be using a get method. Another very common method is the post method, right? Which submits data to a resource. And like it says here, often causing a change in state or side effects on the server. So whenever you want to change something, most likely you're going to be using a post method, right? Because you're going to be telling the thing, hey, I want to change something, and here's what I want it to change to. So the post method has that specification of the data that you're trying to, the data or the thing you want the server to change to, right? The delete method is a method to delete a specified resource. So you'd say, hey, here's this resource right there, I want to delete. And the put method is typically used for kind of like updates inside of a particular resource. So say, take this resource and swap it with this one. As you might be thinking, right? Well, you might be like, well, what's the real difference between like a post and a put and a delete? You know what I mean? Like, can I use a post method to say, hey, I want to change this thing by deleting something? And the answer is yes. Like, it's not like you have to use delete method to delete. You could use a post method to delete. It just depends on how your server is structured and how your routes expect the data to be passed into them. But all these methods are important to know about because you might be looking at a server or you might be working on a system that uses some of these different HTTP methods, and you just want to make sure you're aware that all of these methods exist, and so you can make good decisions as a developer around, hey, here's what I want to use in this use case to make this code work the way I expect it to work. And so for most of your CRUD APIs, right, the get method will be very common and the post method will be very common. And depending on how you choose to structure your server, you might be adding some put methods and some delete methods to round out how you set up all your CRUD routes. But leveraging the get method and leveraging the post method is just a good way to, if so long as you know both of these, you're in a good place, because majority of methods are going to use the get request and use a post request. So those are two that you just gotta familiarize yourself with for sure. Okay, so one more pop quiz for y'all. Whenever I go to my browser, right, and I go to any website and I press enter here in the URL bar, which of these methods is it going to perform? Which HTTP method gets thrown back whenever I go to my browser and I say, hey, yo, go to github.com, right? If I press enter right now, what method is happening in the background? All right, see a lot of different stuff here. Yeah, get method, post method is a get method. Yeah, so we're using a get request because we're retrieving the data from github.com here, right? I didn't post any data to GitHub. I didn't add any data. I didn't say, hey, here's some data for GitHub to have, right? I just said, I want to go to github.com, and essentially, what did I retrieve? Well, I retrieved their HTML page from their server. If we go back to the inspector real quick, we can take a look at this in our network tab. So let me just refresh this and then go back here to our network tab. And as you can see, a couple different network requests are happening on the page, right? Some of them coming back with our status 200, right? 200 level status, little secondary pop quiz. 200 status, what does that mean for us here in the back end landscape? If we see 200, that means we saw a successful request, right? So cool. So if we look at any of these, pieces of data that came back from GitHub, that GitHub request that we just made, I think the reason why, I was like, why is it only showing me images? But that's because I had it filtered. But one of the first things that came back, right, if you see it up here, is github.com, and it looks like a little file, which is a file document that contains the GitHub HTML, ugly as it is without no CSS, right? You see that? That's not the most beautiful, not the most beautiful thing, but it's HTML nonetheless, right? And if we look at that response object, we can see that HTML came back, right? So this is the HTML that corresponds to the GitHub page that comes back at that route. When I press enter on github.com, it sends back this HTML for me, right? If we take a look at the headers of the request, right, we can see that I requested this URL and the request method was a GET request. It came back with a status code of 200. And here you can see a couple different response headers that came back when it sent back that document to me. So to make a long story short, whenever we are working within our browser, anytime you're going here to a URL, to any server on the URL, right? If I don't go away from github.com and I go to Twitter, right? This is also going to perform a GET request to twitter.com, right? And twitter.com, github.com, right? Like we talked about a while back, all of these are just these are domain names mapped to a particular IP address of a server, right? So GitHub has its own server that's running. And when a user like us, a client, makes a request to the server, a GET request, right? The GitHub server is processing that request and sends back a response that says, hey, if you're going to the route, right? If you go to github.com/ or just github.com, right? We're going to send back a file, and that file will be a document, this HTML document. That HTML document clearly has some linked CSS and JavaScript, which makes it so that the page actually loads the way we see it. But just like we're doing in our server in our index.js right now, right? We're sending back a file to a index.html so that when a client goes to our server, which right now it's not hosted on a particular machine with a public IP address, but we can access that IP address with localhost 8000. This IP address, you could think of like localhost 8000 is a local IP address to our machine. But going to this route at the / right, is the same as going to like github.com, right, for us. And we're performing a GET request. We know in our code, hey, we're performing a GET request and getting back this file, and it reloads the browser when it gets back that file. That's literally the same thing that's going on in the GitHub example, or in any example of you using your browser. So cool. If that makes sense to you, give me a thumbs up, because that's a big important point. You know what I'm saying? That's a connect the dots moment right there. you gotta want to make sure those dots connect a little bit, because that's a big point right there, right? Anytime you're on your browser, you're making a bunch of GET requests to these different servers, and those servers are sending you back files, right? And sending you back data and information based on the route that you're going to. All right, Gucci, yeah, that way, great. All right, cool. So let's get back to what we were doing, right? So we have this GET request working well, sending back this data. We also have this /links route that is allowing for us to call our first query to get back this link. We talked about how this is a read method in the CRUD landscape, and we're able to read the data from this query and essentially get this data together, right? We saw that example here where our localhost 8000 / links, we get back an actual array of data from our table. That's because here we're sending that JSON back, and it's clearly sending us some data whenever we go to that link, to that route. So the next thing I want to talk about is, okay, well, that's great. We now know how to read data. So if I have a different table, maybe users, right? And I want to get all the users from my table, right? My users table. I could write a similar structured query to get all of the users from my application, right? So the read method is very important. Is a very important operation in any API that's working with databases, because you're going to want to at some point look at all the data that you have, right? And instead of going to the Postgres interactive terminal and typing this in there, you might want to just have your API get that data and send it back to you in a very easy way. The next thing we want to do, clearly, is we want to create some data, right? We want to add data to our database, right? Give me a thumbs up if you want to add some data to this database. You're like, all right, we've been talking forever. Can you add some data to the database? Right? Yeah, let's add some data to the database. That's what y'all want. That's what y'all came for, right? So if we wanted to add data to the database, right? Which of these 4 methods do you think we're going to want to create? Which of these CRUD methods would we be working with in that sense? I kind of said it unintentionally, but y'all know the vibes. You know what I'm saying? That's what teachers do. Yeah, exactly. A create method. Yeah, right. So this would be, if we want to add data, we probably are going to want to create. So we're doing the create logic here in this CRUD system, right? So we can kind of just start off by just thinking about it functionality wise without getting into the nitty gritty, right? So if I were to, let's just say hypothetically, I have some function that can create some data for me right now, right? So maybe that function is like, create link, right? And it's going to be a function. So I'm just going to write a nice little function here, right? And we'll pause here and we'll figure out what needs to go in here, but got my function created, right? So once this is created, right, clearly to follow kind of the same logical structure that we set up with our other application query, right, with the get links method here, I'm going to want to export this. So I can say create link, right? Export this as another part of this export. And then I would be able to now, because I've imported the database, right? I'd be able to actually create a new route that uses that particular function to get back some data. So here, this is the last question for y'all, then we're just gonna code straight. Remember with Express, we reference the app, and then I have to reference an HTTP method here. Which HTTP method do you think most ties to me creating data on the server? On the database, or which HTTP method that we talked about just now do you think would be the best choice for create method? Oh, I love it. Look at y'all. Look at y'all in the chat. You know what I'm saying? Give yourselves a round of applause. You know what I'm saying? Yeah. A post method. Right. Exactly. Right. Because we're going to be updating some data on the server. Right. So I'm going to have some new method called app.post. Right. And in here, I can pass any route that I want to use here, right? I could say, /new, right? If I want to just say, hey, when someone makes a post request to /new, that will, create a new link for them or something, right? And then clearly here, what we're going to have to do is pass create link, which is the function we just created, right? So this is one way to do this, right? Sometimes you'll see, though, people might use the same route for a get method and a post method because they're different handlers, right? But it kind of creates a consistency within your API. If you have, hey, whenever you're dealing with looking at all the fave links, hey, we're going to call get links. But whenever you want to add a new fave link, we could call post links, right? So sometimes you'll see people use you'll see people use the same route, but with different methods to refer to those routes to then say, hey, one is going to be where you post new links, one's going to be where you get links, right? Just for the sake of keeping it clear in your mind, I'm just going to call it new for now, but you might see in some other code, or if I upload this to Git or something, that it has a different route just later, but just want y'all to be aware of that. The name of your route doesn't really matter, so long as you know which route to call. That's it. You just gotta remember which route you named it so you can call it that. But cool. So got this first bit going. It seems like everybody's kind of clear on this part, right? We got to create a new post request to this route, and we're gonna want this route to then create a link for us, right? So I could save this. I can also save in here. Nothing really is going to change until I relaunch my server anyway. So now we got to figure out, okay, it's not enough to call an empty function. We want to call a function that actually can do something for us. Well, because this function that we're creating here is, because this function is is essentially the callback function for the route, right? It's important that that callback function has the request and the response objects passed into it so we can make reference to those inside of our function. So first thing we want to do is just add the request and response objects in here, and then we can make reference to them here inside of the function body. So this function, any function that we write in the queries that then we're going to export and then call like here in an actual route, that function has to define what happens with the response and what data do we need from the request in order to process things in the way that we would expect. So we can see that example here where when get links was called, we just said, hey, send back this response if it was successful. Otherwise, then we didn't really need to do anything with the request. But in this case, with the create link, we will have to do a couple things with this request, just so we can make use of how post requests actually work. So before we get into like the nitty gritty of that post request, let's just talk about how post requests are structured. So I'm going to go back to the HTTP methods in the Mozilla network, because I'm sure they have some great examples in here. Let's just click on this post request and just take a look. So post request, send data to the server. The type of the body of the request is indicated by the content type header. So remember, we can process all types of data inside of our requests. But in order to tell the server what type of data it's going to be getting back, we pass that in a header called content type. Remember I was saying, oh yeah, this content type thing we're going to talk about in a bit, right? So now's the time to talk about it. Talks here about the difference between put and post. But one of the things it's talking about here is a use case for post requests, wherein it says post requests are typically sent via an HTML form and results in a change on the server. In this case, the content type is selected by putting an adequate string in the ENC type attribute of the form element, or the attribute of the input or buttons element. And here are some of the different types of data that an HTML form might put in the content type. You got application form URL encoded, multi-part form data, text/plain. So here, essentially, it's saying most times, we're creating post requests via a form. Like a form would trigger a post request that would be sending some data in these various content types. There are other ways that you could call post requests though. And as you can see, it talks about that a little bit here if we kept scrolling, right? When a post request is sent via a method other than an HTML form, like via an XML HTTP request, the body can take any type as defined in HTTP, blah, blah, blah. Post is designed to allow a uniform method to cover the following functions. Annotation of existing resources, posting message, adding the user, So basically, it's saying that in forms, these are the three types of data content types that you'll typically have coming back from a form if you handle the post request strictly from the form. If you don't, and you're handling the post request via a different method other than the HTML form, like a regular HTTP request is basically saying here, then the body might take a number of different types. And that's why when we make a post request, right, typically it's important for us to tell the post request what type of data are we sending, right? What's the content type of that particular request? The way we do that is we create what are called headers on our in our request object. So let's go to the where will we go to show you this real quick? Oh, HTTP headers. Perfect. So if you look here on the left side, these are, I wish there was like I wish I could just show you a big list of all the headers, but it doesn't look like I can. Let's see. Maybe. Beautiful. Okay, so headers are used for us to pass like metadata into our request and into the response, right? And we use the headers to essentially communicate certain information into our into the request or into the response that we want the recipient to receive, right? So there's different types of headers: request headers, response headers, right? Request headers are really important when you're working with post requests, because you're going to use these request headers to essentially do a couple things. One is pass information to the server so that it knows and understands how to process our response. And also with that, right, some of the various things that we might tell a server are things like, hey, the content type of a particular bit of data that I'm sending in. In addition, like it talks about here, remember that CORS stuff that I was talking about? And we're like, oh, CORS. Sometimes when you're trying to create a resource sharing across your different server instances, you need to actually pass some headers into your requests to allow for the server to accept your request by default. So if your server and client aren't on the same server, the way around CORS actually is really all about creating different headers on your requests for your server to accept. So this is a little bit more advanced from where we're at right now, but just the point I'm trying to make is that we need these HTTP headers to pass certain metadata into our requests that will allow for our server to process the request the right way. That makes sense? Give me a thumbs up. You know what I'm saying? The headers contain information that the server is going to read and then utilize to process our requests the right way. And so in certain cases, we need to be very clear about the type of headers that we're passing in. For the post request, right, the one that's really important is the content type header, which is where we say, hey, what type of media are we passing into this request, right? So this is literally what this means here, right? In request, the client tells the server what type of data is going to be sent, right? I think it will tell us here. Does it give us some examples of the different content types? I wish it did, but it didn't. There's a number of different content types, like we could kind of just saw, right? From the form, we saw the text, plain text, the multi-part form data, right? There's all these different types of data that we can specify from within the content type header. Some of that is here. We can see it here again, but one of the content types that we like to pass is JSON, right? JSON data. So depending on the type of data that you're sending, you might specify a different content type header in order to let the server know, hey, this is the type of data that I'm sending, right? So in order to work with your server on a post request, you got to just be very clear on what data is the server going to expect and what data am I going to pass in to the server. So let's finish up this post request, and then it will hopefully make a little bit more sense after we see some actual code. So right now, we have our function created, right? And we just need to figure out how we're going to actually make this this post request, and what do we really want it to do, right? So essentially, what we want to do is we want to essentially, whenever a user is ready to actually create a link, right, they're going to pass us some data, right? So we want to take the data the user passes us and insert it into our table, right? That's essentially what we want this method to do. Just like here, we want it to just get back all the data from the server. Let me just annotate this. Get back all the data currently in the database, right? That's what this last query did, was get back all the data currently in the database. Now we want to take the data that the user passes us and insert it into our table, right? So how are we going to do this? Well, in order to do this, we're going to really rely on the request object more than we have previously. When you're working with GET requests, typically you don't really need to do too much with the request object, right? You might just have it in your function and it's not doing anything. But with post requests, you're going to do a lot with those request objects, because the request object is going to have the headers responsible for the type of data you're passing in. It also is going to contain the data. So how the request holds the data is somewhat dependent on the structure of the query itself, or the structure of the route itself and how it passes it. But one common way that a request object, let me see if the request object is in here. One common way that a request object passes data is through what's called the body. And the body is a property of the request object that contains the data that you can pass into a request. So when you want to pass data into a request, you have to note, hey, it's going to be this type of data, but you also got to pass the data, right? Typically, the data will live inside of the body of your request, right? And so in order to make use of that data, right? In order for me to like, hey, say I want to get this data, I need to take it from the body of the request. And that's exactly what we're going to do here. So essentially, we're going to expect that the user is going to pass us some data in the request body. That data might mirror what we're used to seeing in our FaveLinks app, right? Maybe because if you remember how the FaveLinks app worked, right? They're going to pass a name and a link, right? So we might expect that, hey, maybe the user is going to pass us a name, right? And that's going to be inside of our body as name, right? The user might also pass us a URL, and that might be stored in the body as a URL, kind of like so, right? So the body is kind of like an object, right? And the object has keys and values that we can reference in order to get back data coming in from the request, right? So essentially, as we're making our post requests, we're able to pass this data into the body and then utilize that data in the process of determining what we're going to do as a response from the server. So right now, we're gonna assume, okay, the user is gonna pass us a name in the body and pass us a URL in the body, right? And what we're gonna do is we're gonna take our Postgres table and we're gonna just make a new query, right? And we're gonna add to our table, we're gonna insert some data into the table, right? So we're gonna just make a nice little Postgres query here that's just gonna say, hey, insert into our table links. We're going to say name and URL, right? So we're just going to remember our links table contains rows of names and URL pairs. So here, when I say insert into links, I'm specifying which columns I'm going to be updating here. And then I got to pass the values, right? And I say values. One way to pass values into a Postgres query that is coming from like JavaScript or like external is to use the, you can pass data as parameters in your Postgres query. So we could do that by just saying $1, $2, and then the query will expect after this that we're going to pass in an array of those values that we're going to expect to be passed into this query here. So this is just the Postgres query or the SQL query to add to a table, right? But now we're just going to pass in the data that we got back from our request. So the client's going to make this request with a body. The body we're going to expect has a name and a URL. And if it does, right, then we're going to insert this stuff in here, right? And if all goes well, right, if all goes well, this will call back a call. This is going to call back a callback function regardless. If everything goes wrong, we're going to get back an error. If everything goes right, we're going to get back results, right? And if there's an error, just like we did before, if there's an error, we're just going to want to tell the server to say, hey, there was an error, right? And let us know, hey, there's an error, you know, stop what's going on here. Otherwise, we're going to tell the server to use the response, right, to send back a response to the client. So this response, we're going to send back with a status of, let's say, 201, which is just another success, and say send. We could say, or, you know, we can say response.status with this particular status. And then we can say send, and we can pass in a nice little string or something that says link added with ID. And the results object in our Postgres will come back with an insertion ID if this insertion was successful. So here we can say results.insert ID, which basically will allow us to just get some eyes on whether or not this was successful. But it all starts with us being able to get back this information from our server, from the request that a client is going to make. And so we're going to take a look at this in a second to just make sure that this works. And just making sure, just looking over my work real quick. And I think this is good. So I'm going to save this. And cool. So now we have this route new with a create link, and we have that route is going to take the request body and information, and it's going to add it into our table. If it's successful, if it's not, if there's an error, it'll tell us there's an error. Otherwise, it'll send back a status 201 with our insertion of our link. This syntax here, right here, is just the JavaScript syntax for creating a, so this syntax right here is for us creating the templated string in JavaScript. This syntax up here is for us to create a data placeholder in the Postgres query that basically allows us to pass in some data outside of the query itself. So basically, this is the query, like what we would have typed into the interactive terminal for Postgres, right? Remember, we did this where we added a link to the Postgres database and passed in, like, I could have passed in a string with, like, test, and here would have been like test.com, right? But instead of passing it here directly into the Postgres query, because this Postgres query takes in a Postgres string, I can't just use the JavaScript syntax here the way you would expect. So in order to pass this data into the Postgres query from external, I have to use these data placeholders. And so the $ syntax here is basically saying, take the first thing in this array that I'm giving you and the second thing in this array that I'm giving you, and send it and add it into this particular query. So we passed in the string for the query, we passed in the data as an array, and then these $ are going to refer to each of the data inside of this array when it finally makes the query. So that's what's going on. That's what's going on there. But yeah, so cool. So now we have a new query to the table, and we're making a new request there. So I'm gonna save that. And then just to make sure that this is all working, I want to go ahead and make a quick change to our client code to just see to make a post request and make sure that we actually can make that post request, get back some data the way we would expect it. And yeah, and just kind of have everything working the way we had before. So in the link container, I was doing previously kind of a fetch call to get back all the links, and I was just kind of calling the use effect there. What I'm going to do is I'm going to just make a different function here. Let's just call it create link, or let's call it post link or something. This is also going to be an asynchronous method. And what I'm going to do with this method is a similar kind of logic of posting to the database, right? Of course, eventually with the Favelinks app, I'm going to want to be able to post a Fave link, like, hey, when I'm ready to go with the link, I want to call this method and pass the right link. But for now, let's pretend we have this test link that I'm going to create an object out of, give it a name. We can call it test, give it a URL of test.com. And so now we have like a test Fave link, right? So cool. So with that test Fave link, what I want to do is make another API call from the client side, right? And just like before, in order to make this API call, I'm going to create a try catch block just to make sure that if there's an error, I can process the error, but I can also try to do as many of these asynchronous tasks as I can, right? And we're still going to do what we did before, which is make a fetch request, but this fetch request is going to be structured just a little bit different in order to make it known that we're going to be posting data and sending that data. So this is where all this stuff hopefully will come together. So here, just like I was talking about before, we're going to create a new fetch request, and we're going to wait for the response. So we're going to say let response get await fetch, right? And this is just very similar to how we did the first fetch links, right? Hey, let response get this route, and if we get it, console log it, show the data, console log the data, etc. So we're doing something very similar here, except the general fetch request sends a get request. It doesn't send a post request by default. So when we want to structure a post request, we have to be very specific with the fetch request that we're going to make a post request. And the way we do that is by adding some configuration to our fetch request to tell it that it's going to be a post request. First, I got to pass in the route that it's going to go to. So I'm going to go to /new, which is the route on our server. And then I'm going to pass in some information. They call it request information, right? Request info. So this object here is going to be an object where I can pass in some information for the request as like different info for the fetch request to process as it's making its request. One big piece of information when you're working with fetch as a library in JavaScript is the method. So you can call a specific method as a fetch request by you can call a specific method as a fetch request by just adding in this configuration object method as a key and then the value of your particular type of method that you want to hold, right? Secondly, right, another type of data that you might want to pass into your requests that you're making to your server are the headers, right? So remember all these headers that we were just talking about before, right? So I might want to pass, or I might have to pass specific headers into my request at any given point in time, right? For now, just to make it clear to the server that I'm passing in content type of JSON, I'm just going to let it know that, hey, I'm sending some JSON data. So this is showing that the content type is going to be JSON. And this is just to show like, okay, we're going to create a header of type JSON. Part of the reason we're doing that, if we go back to our server, is because if you recall, right, we pass this middleware that says, hey, you know, we're going to parse the JSON if the content type says it's JSON. That way we don't have to do all this extra logic to look through the body and get the JSON. It'll parse the JSON it'll parse the JSON for us if it reads that the request is using JSON data. And the way it reads that a request is using JSON data is if the header says, oh, I'm passing you JSON data. And that's what we're doing specifically here in the client side. This is just an example of headers, right? So, you know, based on what your server needs, you might need to pass other headers, but this is just how we might do that with a fetch request. And then lastly, right, outside of the method and the headers, the third most important thing that you might have to pass in a request is a body of data, right? And in that body, you might have to create in that body, you might need to pass some data that server is expecting you to have, right? So if we look back at our queries, remember I said, we're expecting that the request is going to have a body.name and a body.url, right? So the name and the URL have to be present in the body data for this whole request to work, right? So here in this body, we have to make sure that we actually have a name and a URL present. And turns out that in the test link we do, right? In this JavaScript object for the test link we do. But, you know, we just want to make sure that that's the case and that we are able to very easily, that we're able to, you know, if body.name is present, body.url is present, great. Because if they're not, we might get some errors that we don't want to have. So the last thing I want to do in order to pass this test link as data is I want to send it as JSON. And the way that we send it as JSON most often is by stringifying the JSON data as a last step. So I'll use the JSON library and I'm just going to say JSON.stringify. And I'm going to take that test link and just pass it in here. So what this is going to do is, you know, this is a JavaScript object. The JSON.stringify method just takes a JavaScript value and turns it into JSON as a string. So JSON itself is typically text, but it's text that refers to a JavaScript object. So you might be like, well, why would I need to make a JavaScript object like test link into JSON if it's already a JavaScript object? Well, it is on the client side experience, but when we're we're transporting this data from our client to the server, we need to make sure that that data can get sent over in a format that is clear in the transportation process. So by sending it as a string of JSON, we're just ensuring that this data is also going to get there as a string with that same JSON format. So JSON.stringify can take any JavaScript object that you have and turn it into a string of JSON that you can then send in your client side calls. So now we have a great first response, right, to we're waiting for this fetch request. So this is a pretty big fetch request right now compared to what we saw before, right? Before we were just kind of doing one line fetch requests, which were just fetching. It's just like doing a simple GET request, right? But like I said, once you start getting into post requests, you need to specify a little bit more data to your post request for it to work the way you expect. And some of those things are the things we see here. First, we got to tell the fetch that we're doing a post request. Next, we got to pass any necessary headers that the server might be looking for. And then lastly, we got to say, hey, if I have to pass some data, make sure I pass that data in the body. Clearly, the test link has all of the different values that the body is going to be looking for in the server. But this is all the process of just ensuring that we're getting we're sending the right data to the server in the format that the server expects. And if we do that, hopefully, right, this response will process correctly. And if that response processes correctly using the async await syntax, right, which allows us to mark a function as async and avoid kind of all those .then, .catch kind of things, we're saying, hey, using this asynchronous function, we're going to wait for this fetch request to get done. Once that fetch request is done, we're going to have this new value called response. if there's an error, we can just console log our error, right? Right, if the server throws an error, right, which we know it will throw an error if something goes wrong here, right, if there's an error in any capacity, we can console log that error. But also, we can, if there's no error, right, we can start manipulating this response object. So the response object is going to, we could console log it just to make sure that it came back first, you know. Then lastly, we might want to just get back that message, right? So remember, we send back a nice little string message for the data, right? So I can just make sure that I get back that string and just say, let's say let message get response.text, right? And if we get that message back, then if we get this message back, we can console log it, right? Console log the message. Otherwise, if response.text also throws an error, then this error, catch error, will go into play. So a lot of different kind of parts to this, but let's just get to the last part to just see if this is going to work. So first thing I did was I just created this post link method, right? So the last thing I want to do just to test this on our client side app is just to make sure I call it inside of that use effect. So now when the app loads and the link container loads, this post link method is going to get called. Post link is an async method that is responsible for taking this test data, and then it is going to try to write that test data. It's going to try to post that test data, right, to our server at /new. We know it's a post request. We know it is going to send JSON, and we know it has this JSON as data. If everything goes well, we're going to get a response back. We're going to get the text from that response back, and we can console log all of that. Otherwise, we're going to catch the error and just console log it. The only thing I want to do now is just say, just because I kind of did the test like this, I just want to make sure I say something a little bit more neat, test, and then I'll just put the time. Let's just say 5, 1, 2, 3. Test.com is cool. So dope. Yeah, I think this is good. So let's test this. So this is just a good opportunity to just kind of go back over what we talked about last class on how this client side all works, right? So now that I made a change, I made a couple changes. The first change was on the server side, right? I changed the server by adding this new route. I also changed the server by adding this new data into the queries in this new function, right? So the first thing I got to do in order to get this to work well is I got to go back to my running server, right? And that's happening here. Let me just stop it. Oops, stop the server, clear. And then I forgot. Yeah, and then I want to restart the server. So I'm just going to do node index.js one more time. And that would restart the server, right? But prior to restarting the server, the last thing I got to do is I got to make sure that I rebuild the client. So if we go back, right? So in the folder that we're in for it, in the folder that we're in for our application, right? We got our client side folder, right? So I want to go to clear this out. I'm sorry, I don't know why this is tweaking, making it so hard for me to zoom in. It's kind of crazy. Anyway, I want to make sure I go into the client side folder, right? And I want to make sure that I do an npm run build, right? So npm run build is going to rebuild the client folder, this client build folder for me, and make sure that, hey, this client build folder is updated because I just changed some of the code components inside of this client, right? Like the link container now is updated. So on top of restarting the server, I have to make sure I rebuild the code in the client so that it is all on the latest version. So in order to do that, I'm trying to see if I could just make this bigger for y'all. Okay, there it is, I guess. So in order to do that, right, I gotta do the npm run build. What that does is it goes ahead and just rebuilds the application, creates a new build folder for me, and it says, hey, you're ready to go with serving it up. Because the build folder is different now inside of the because the build folder is different, right, inside of the bigger server, right? So the client folder got updated with this build folder, but the server was hosting the old version of the build. So I got to also make sure that I restart the server one more time, so that it has the latest version of the client as well. So now I got this server back up. I want to make sure I have an inspector window open for it. And so just go ahead and open an inspector so we can see some of these console logs that we called. And then in here, just refresh the client, go back to our console, and cool, we see a couple things going on. We got a response. Response actually came back positive. We got our body with our okay true going on in there. Status 201 created, and we see that our text, what is going on here? The promise. Oh, okay. So the promise kind of came back as well. Says the promise was fulfilled and link added with ID. It was undefined, but that's interesting. So let's see if it got added. We could go to localhost 8000/links and just refresh. And yeah, we see a couple things in here. So if I zoom in, right? So test 5123 URL test.com. So clearly our post request actually worked, and it added to our the app, which is dope. So yeah, just remember that in order to have it work, right? If you are following along, because I saw in the chat, right? Make sure that if you made the new route, you stopped your server, right? And you restarted your server, because you need to, it won't know that if the server is not on the right call. Second is make sure that when you make that request, that is also knowing that it's a post request, because if you're trying to get to this route and it doesn't know that it's a post request, it might not find this route. Secondly there. And thirdly is, just make sure that you have the route in there for your app inside of your thing. And if not, we can take a look at it in a couple seconds. I'm curious, like, where am I drawn here? So I got this res send link added results insert ID. But yeah, I guess that's cool. So we have the ability now to add links to our database, right? The way it works is using these post requests, right? And on Wednesday, we'll go over these a little bit more right after we finish up thinking about some of these other parts of the app. But now with this logic, right, we added another method to our CRUD functionality, right? So now we can create new links into our table. We can read them. The last two, if we wanted to get to all of the CRUD methods, would be to be able to update specific ones and delete specific ones. But the way we could do that, right? Well, if you remember, each of these links, when they get added to our table, has a particular ID. So if we make a route that targets a particular ID in the table, right, we can get back a particular record and then do what we want to do with that data, and then edit that data, update that data, right? So we can create another route to do that. If we wanted to delete, it's the same process, right? We can just target a specific ID of a particular fave link that we want to get thrown away here. And from there, we can delete it off of just which ID does it have, right? So that's dope, right? And it can help us out tremendously in the process of sending this data. And then, the only thing that's missing now is, like we talked about, and this is a big part of what y'all are trying to figure out, is how do we make the client side experience actually call these API calls when they're needed to be called, right? So if you think about it, when would we want to call post link? It's not necessarily in the use effect whenever the app loads. That's not where we want to actually call this. But we might want to call it, whenever a user says, hey, I have a new fave link for you and I want you to add it to your table, right? Um, in addition to doing it in the React side so that you can see it in the state, we might also want to then call some of these API calls to then say, hey, take that fave link, right? And maybe it's like, new link. And instead of having this test link here, right, I can just do a JSON stringify with the new link, right? All of this would be helpful in making it so that our application is not only just saving data locally, but also sending it to the server. So more to come, more routes to work on, more things to talk about. But I appreciate y'all for your time and your attention today. And of course, if you got a question, you want to hang around, that's cool. If not, appreciate y'all and